Right. Now, when we consider people two vectors A and B like this, with the angle between them is theta. This angle theta is an angle line between 0 and 180. Okay, 0 and 180. Theta less than or equal to 180 degrees, greater than or equal to 0. Right. Now, here we define the A dot B. This is called as people dot. Dot. A dot B. A dot B, we define mod A, mod B, cos theta. Mod A, mod B, cos theta. Mod A, mod B, cos theta. Mod A means size of the vector A, mod B size of the vector B, cos theta. Theta is the angle between A and B. Now, this right hand side people between mod A, mod B and cos theta, we have multiplication, the usual multiplication. We have the usual multiplication. Okay. Mod A is a value, a real number. Size of vector, no, real number. Mod B also a real number. Cos theta also a real number. Cos theta can take any value between +1 and -1. You know, according to the behavior of cos theta graph, that cos theta graph fluctuates between -1 and +1. So therefore, this right hand side, this is a real number, this is a real number, this is a real number. Then here on the right hand side, we have the usual multiplication of these three real numbers. Okay. So then people, the answer of A dot B we get is finally a real number, because the product of this three real number is another real number. Therefore, final answer is a real number. Real number is a scalar. Since the answer of A dot B is a scalar, this product is sometimes known as people scalar product. Right? Vector scalar product, vector dot product or vector scalar product. Right. We learned last week three properties like this. Now, when we consider B dot A, when we consider people B dot A, right? B dot A. B dot A, when we write modulus of B, modulus of A, again between A and B the angle is theta, therefore cos theta. Now you can see here, if we take this mod B is 2, mod A is 3, cos theta suppose we get half, then here we have 3, 2, half. You know people, this 3 when we multiply, whichever the order of multiplication of three real numbers, the answer will be the same. That means by interchanging the multiplication order of n number of real numbers, the answer won't change. Answer won't change. So therefore, this right hand side and this right hand side become equal. So therefore, the left hand sides should be equal people. A dot B is equal to B dot A. Right? A dot B is equal to B dot A. That is first property. What is meant by that? When we interchange the vectors, whenever we take the dot product, the answer won't change. A dot B is equal to B dot A means by interchanging the order of taking the dot product between two vectors, the answer won't change. That's what this result says. That is to say, when we multiply two real numbers, 2 multiplied by 3 is equal to 3 multiplied by 2, no? Similarly, when we take the dot product between two vectors A and B, A dot B is equal to B dot A. Okay, that's what this is. Secondly, people, another property we learned, we take dot product of vector A with itself, A dot A. A dot A, then according to this, we can write mod A, again mod A, cos. People, when we consider vector A, the angle between vector A and vector A is 0. Then here we get cos 0. But you know cos 0 is 1. Under trigonometry, we learned that cos 0 is 1. Then we get A dot A as mod A squared into 1 is mod A squared. Therefore, people, we can subject this one, A dot A is equal to mod A squared, mean mod A squared is equal to A dot A. This result says, people, if we need to find perfect square of the modulus, perfect square of the modulus of a vector, that can be done taking dot product of that vector with itself. By this, when I subject people mod A, we can subject this mod A, taking the square root of the right hand side. This way we get. What is this, people? Modulus of any vector can be found taking the square root of that vector with itself. Okay, right. That is second property we learned. Third property, people, we learned, we can find A dot B means mod A, mod B, cos theta. Then this cos theta can be subjected, right? Cos theta is equal to, by mod A, mod B product, we can divide both sides, then we get A dot B divided by mod A, mod B. Then this cos theta means theta is the angle between A and B. Its cos value is this cos theta, right? Then the angle between two vectors can be found by using the formula this. It is what, people? Cos theta is equal to A dot B divided by mod A, mod B. This we did, right? Yeah. Right, people, that's all we did. Now, today we can do some theories and we can go to the next part, right? Number 4, people. Fourth property. Fourth one is implication of A dot B equals 0. What is meant by this implication? Implication means the results we can get by this A dot B equals 0. That's the meaning of implication. Yeah. Let's see A dot B when we define, people. This is mod A, mod B, cos theta. Right. If A dot B is equal to 0, that means this is 0, no? This implies if this is 0, mod A times mod B times cos theta, mod A times mod B times cos theta is equal to 0. If all these three, mod A is a real number, mod B is a real number, cos theta is a real number. That product equals 0 means product of three real numbers is equal to 0. This can happen under three cases. This implies, people, mod A equals 0 or mod B equals 0 or cos theta equals 0. These are the possibilities. Mod A equals 0 means, people, modulus of the vector A0 means A should be a null vector. A vector should be a null vector. Or mod B equals 0 means, people, vector simple V should be null vector. Or cos theta 0 means, people, for cos theta to be 0, 0 should be 90, pi by 2. Theta 90 mean, people, the two vectors A and B are perpendicular to each other. This means vector A is perpendicular to vector B. This is how we write in short form, perpendicular. So therefore, people, we can write the result. Therefore, if A vector dot B vector is equal to 0, this implies three possibilities. What are the possibilities, people? Vector A is a null vector, or vector B is a null vector, or the two vectors A and B are perpendicular to each other, right? Implies A vector is a null vector, or vector B is a null vector, or vector A is perpendicular to vector B. These are the, people, possible outcomes when this A dot B is equal to 0. Okay? But people, suppose when this A and B are not null vectors, when A and B are not null vectors, A dot B equals 0. Then what is the result we can take? A and B, the two vectors are not null vectors, not 0 vectors. Right? When A and B are not 0 vectors, A dot B is 0. Since, people, A and B are not null vectors, then this A dot B equals 0 can occur under this cos theta equals 0 only. Why? This time this can't be 0, because mod A equals 0 means A is null vector, no? When A and B are not null vectors, when A and B are not null vectors, this mod A is not equal to 0, mod B is not equal to 0. Then this and this both are not equal to 0. Then for this product to be 0, definitely cos theta should be 0, no? Now, for example, suppose mod A is 2, mod B is 3, cos theta 0. Then 6 cos theta, no, here. 6 cos theta 0. When you multiply 6 and cos theta, the answer is 0. Definitely, to get the answer 0, multiplying 6 by a number, that number should definitely be 0. Then only 6 into 0, the product will be 0. Therefore, when A and B are not null vectors, and if A dot B equals 0, implies, people, A vector is perpendicular to B vector. That is the method, people, we use to say, if we need to show that two vectors are perpendicular to each other, we show the dot product between the two vectors is 0. Right? Then that also we can write here as a result. Right? First, take down here, people. Right. First, take down this, and I am going to write a note. What is the note? When A is not null vector, vector B is not null vector, And if A dot B is equal to 0, then you can write this implies vector A is perpendicular to vector B. Vector A is perpendicular to vector B. Correct now, people? A vector, B vector, the two vectors are not null vectors. Not null vector. But A dot B is 0. But A dot B is equal to 0. Then that A dot B becomes 0 should occur only when this A is perpendicular to B. Otherwise, no chance of A dot B equals 0 can occur. Right. Write down that note also. Here is the property number 4. Property number 5, people. Distributive law. Distributive law. Distributive law. Right, this is the people distributive law. Right. Now, you know, when we have 2 times x plus y, this bracket we can remove this way. 2 into x plus 2 into y. People, here between this x plus y and this 2, we have a multiplication sign. Now, suppose here as the 2 we have vector A, and for the multiplication sign we have dot product. Within bracket we have sum of 2 vectors B plus C. And now here we have, people, dot product. Now this vector is B plus C. Within bracket we have sum of 2 vectors. This is A. Now this distributive law says, people, we can remove the bracket like this. A dot B plus A dot C. This we can take with this, and the same thing we can take with this with the middle sign plus. That means in the same way, this we can remove the bracket. A dot B plus C is equal to A dot B plus A dot C. That way we can remove the bracket. That is called as, people, distributive law. Understand? Right? This one we can prove, but really we don't prove that here. That is not that much important, but the proof is very easy proof. Okay? We'll learn what is distributive law, and you should understand how to use that distributive law. Right? Write down that. A dot B plus C is equal to A dot B plus A dot C. This is the distributive law. Number 6. Number 6. Implication of A dot B equals A dot C. Right. A dot B equals A dot C. Implication means, people, by this equation, what result we can obtain, or what result it says. That is the meaning of implication of A dot B equals A dot C. People, at once, you might get the idea that here A we have, here we have A. With this A, vector B is taken the dot product. With the same A, vector C taken the dot product. The two results are equal. Since both sides we have A, this B and C vectors should then be equal. That kind of idea you might get. It's true. But it is not the only one result by this vector equality we get. That result you thought is correct. But what I'm trying to tell you is, people, it is not the only one result available in this equation, vector equality. Let's see what are the others. People, now I can take the right hand side A dot C to left hand side. It wants to take this A dot C to this left hand side, people. On the right hand side, no figure available. That means 0. 0 is available. Now, really, people, we can use to this left hand side the converse of the distributive law. People, see here, A dot within bracket B plus C we have. Subject to this distributive law, this one we can write as A dot B, A dot C. That means taking dot product of this B and C with this A. If we have this way, we can write it like this. Then, can somebody tell me, using the right hand side, how to obtain the left? It is this. The right hand side, A common, take A out with this dot in front of it. Now open the bracket. Once you take this A and dot out, this B within bracket should be, and this C within bracket should be. You can see now by this we get this. Like that, I can apply here that way the converse of the distributive law. So once I take this A and dot out, within bracket we have B minus C is 0. This way we get. Now, people, what can you say here? A is a vector, B minus C is another vector. This is a vector, this is a vector. The dot product of two vectors we have. Dot product of two vectors is 0. People, today we said, if A dot B is equal to 0, under property number 4 we discussed, if A dot B is equal to 0, we said what? That implies either vector A null vector, or vector B null vector, or vector A and B are perpendicular. Like that, B minus C is a single vector. When we subtract a vector from another vector, answer is another vector. So therefore, this B minus C is a single vector. This A dot this vector equals 0 mean, people, this can happen, vector A is null vector, or vector B minus C is null vector, or vector A is perpendicular to vector B minus C. They are the possible results we can write. Once you write those results, people, not only that, this equality at the beginning we thought A dot B equals A dot C implies B, C vector should be equal. Including that, another two more come in by that. Understand? Right. So then this says, people, what? Vector A is a null vector, or vector B minus C is a null vector, or what do you get, people, next? vector A is perpendicular to vector B minus C. Right? Vector B minus C. People, by this only, taking this C to right hand side, this gives us vector B is equal to vector C. So then this is the one we thought, but that is only, that is the one solution. In addition to that, another two more results available in that. Okay, so therefore, we can write finally, this implies that vector E is null vector, vector B is equal to C vector, or vector A is perpendicular to vector B minus C. Correct, no people? Right. Right, no? Yeah. Okay, now we'll take some questions in the tute. We'll take some questions in the tute. Right, now people take your tutorial. Take your tutorial. In your tutorial, take question number 68 as the very first question. Question number 68. Take question number 68. And question number 68 says people something like this. Modulus of vector A is 3. Modulus of vector B is 1. Modulus of vector C equals 4. And given another one more, vector A plus vector B plus vector C is equal to null vector. Then we have to show A dot B plus B dot C plus C dot A is equal to minus 13. Right. To take this answer, this is what we do, people. I take this A plus B plus C is equal to 0 vector. No? People, you know, when we have this way, right, an equation, both sides we can multiply by any number. Both sides we can multiply by the same number. The left and right, even after multiplying, become equal. Right? Like that, people, when we have two vectors are equal, the left and right, we can take dot product with the same vector. With the same vector means A is equal to B. The left hand side and the right hand side, we can take dot product with another vector. Suppose C is another vector, then the left hand side we take dot product with C, the right hand side we take the dot product with C. Since A and B vectors are equal, this is also equal. Okay. Like that, people, here the left hand side, this vector is equal to null vector. Then I take dot product of both sides with the vector simple A. Okay, then we can write taking dot product with simple A vector, right? Then this one A vector dot A plus B plus C is equal to vector A dot null vector. People, when we take dot product of a vector with null vector, the answer is 0. The reason, when we define A dot null vector, people, how to define this? Vector A, vector B, vector not B, vector 0, and cos theta coming now. Here, modulus of null vector is 0, people. Whichever this takes, people, finally that product should be multiplied with this 0. You know, when you multiply any real number by 0, answer is 0. So therefore, the right hand side is 0 vector. Now people, you can use that distributive law. How? A dot A plus A dot B plus A dot C. Like that you can remove this bracket. Right? How? A dot A plus A dot B plus A dot C is equal to 0. Okay. People, what is A dot A when you take dot product with the same vector? A dot A. We said what, people? By A dot A we get what? Perfect square of the modulus of the vector A. Understand? Okay. This is there. Oh, mod A squared plus A dot B plus A dot C is equal to 0. Right now, people, we said when you take the dot product of a vector with itself, what is the answer? As the answer, what we get is the perfect square of the modulus of that vector that we know. So here, that is why I wrote for A dot A, what mod A squared. But given that mod A is 3, then here mod A squared we have this is 3 squared. A dot B plus A dot C is equal to 0. 3 squared is 9, people. This 9, you can take right hand side. That is minus 9. So therefore we get A dot B plus A dot C is equal to minus 9. See, this is number 1. Right. Similar people, do another 2 more. What are those? This one, A plus B plus C is equal to null vector. Both sides take dot product with vector simple B and take this result, right? And thirdly, take dot product on both sides with vector C and take the third result. Then these 2 results, naming them as 1, 2, and 3, you can add them up. Once you add them up, people, you will get this answer, right? You will get this answer. Okay, I'll give 5 minutes. Try to get this answer. Try to get this answer. Right, now we'll take second one. Taking dot product with B. A plus B plus C is equal to null vector, no? Is equal to null vector, right? Then I take dot product on both sides with vector simple B, right? Then I take like this, A plus B plus C. I take with dot product with B vector, then B vector dot null vector on the right hand side we have. This is people 0, B dot null vector is 0. Then remove the bracket. B dot A and B dot B and B dot C. Is 0. People, B dot A is same as A dot B. We learned one property of dot product. A dot B is equal to B dot A. When you change the order of taking dot product of two vectors, the answer won't change. B dot B means what, people? Mod B perfect square. We said what? When you take dot product of a vector with itself, then what's the result? Its modulus perfect square coming. And this is B dot C is 0. Mod B means, people, given as 1. So this is 1 squared. B dot C and here A dot B is equal to 0. 1 squared is 1. Take that 1 to right hand side. That will be minus 1. You see, we get this is number 2. Right? Third one. We take dot product on both sides with vector C. C dot A plus B plus C is equal to C dot null vector. Remove bracket by using the distributive law. C dot A plus C dot B plus C dot C is equal to 0. Because C dot A is same as A dot C, no? Why we know? Though we interchange the order of taking dot product, the answer won't change. So therefore, C dot A I can write as A dot C. C dot B I can write as, people, B dot C. B dot C. C dot C is nothing but mod C perfect square equals 0. But people, mod C given as 4. What do you get? This is 4 squared. A dot C plus B dot C. This 4 squared is 16. Take that right hand side, that is minus 16. Then here we get A dot C plus B dot C. This is third, number 3. Okay. Now, what we do is, people, we add this 1, 2, and 3. We add this 1, 2, and 3. We add this 1, 2, and 3. How to add 3 equations, people? 1 plus 2 plus 3. How to add them? The left hand side we add together, right hand side we add together, right? Yeah. Then you can see, when we add left hand side, here A dot B we have, here A dot B we have, and this doesn't contain A dot B. A dot B plus A dot B is 2 times A dot B, right? A dot B here we have, A dot B here we have. A dot B plus A dot B means it's like x plus x, no? X plus x is 2x. Like that, A dot B plus A dot B. What is that? 2 times A dot B. 2 times A dot B. This way. Next one. Here we have A dot C. Here we have A dot C. 2 times A dot C. And people, here we have B dot C. Here we have B dot C. When you add them up, we get 2 times B dot C. This is equal to right hand side, people, minus 9, minus 1, then minus 10, and minus 16, minus 26. Minus 26. Now we divide both sides by 2. We divide both sides by 2. We divide both sides by 2. Then what do you get? This 2 and this will cancel off. This and this will cancel off. This and this will cancel off. Right hand side minus 26. When you divide by 2, we get minus 13. Then we get A dot B plus A dot C plus B dot C is equal to minus 13 is the answer. Is the answer, people, right? Right. As the next question, people take number 69. Take number 69. Read number 69, people. Just try to get this number 69. The answer. Number 69 says vector A plus B plus C. Vector A plus B plus C equal null vector. Vector A modulus is 3. Vector B modulus is 5. Vector C modulus is 7. So that the angle between vector A and vector B is 60 degrees. 60 degrees. Right? 60 degrees. Yeah, people? How take that? Angle between the vectors A and B. Just think here. Yeah. We're supposed to take the answer like this. This relation is given. We start from there. A plus B plus C is null vector. Now, I can subject this vector C, taking both this A and B to right hand side. It's minus A vector and minus B vector. Then I can take minus sign out, vector A plus vector B come in within bracket. Okay. Now, of the result, this says the left hand side and right hand side vectors are equal, no? On both sides, I am going to take the dot product with the vector simple C. That's possible to do, no? Left hand side and right hand side, the two vectors are equal. Now I am going to take dot product in the left and right with the vector simple C. Okay, then we can write here, taking dot product on both sides with vector C. Then what do you get? C dot C, left hand side. Right hand side, minus A plus B vector dot C. Correct, no? Now, people, this C mean, vector C mean here, this. Then for this C, vector C, I can put again minus A plus B. Then C dot C. C dot C is what, people? Mod C perfect squared. We know when you take dot product of a vector with itself, what do you get? The modulus perfect square of that vector is the answer. Right. Now right hand side minus a plus b dot a plus b dot. You see me in people again minus a plus b. Now this minus and this minus we can multiply. It's plus. Now we have a plus b dot a plus b. Left hand side mod c perfect square. But mod c is 7, then it's perfect square. Now people here, for this right hand side, you can apply distributive law. What is distributive law? When we have two brackets like this, how do you eliminate the brackets? In the same way, you can use this dot product too. So how to take this? A dot A and A dot B and B dot A and B dot B. Understand? That way you can remove the brackets. Right, so then we can write this 7 squared is 49. A dot A. And next one plus no plus A dot B. Right. Next one is plus B dot A and B dot B with plus sign. This is what we right now. Okay, no? Right. Right now, people, B dot A is same as A dot B. Then this is A dot B plus this is A dot B. A dot B plus A dot B is like x plus x. X plus x is 2x, no? Like that, A dot B plus A dot B is equal to 2 times A dot B. And B dot B is people mod B perfect square. Right now? Yeah. Mod A squared. Mod A means 3. So therefore, this is 3 squared. This is 49. 2 times. People tell me how to write A dot B. Mod A times mod B times cos theta, no? Right. What is this theta? The angle between A and B. Mod A times mod B times cos theta. Mod B squared means people 5 squared. Mod B is 5, no? Right. Now, this is 49. This is 9. 2 times mod A. Mod A is 3. Mod B is 5. Cos theta. This is 25. 5 squared is 25. We will now bring this 9 and that 25 this side, right? 25 plus 9 is 34. Once you take the 34 to this side, 49 minus 34 is, this is 15 in the left hand side, no? And here 2, 3, 6 into 5 is 30 cos theta. 15 equals 30 cos theta. Now divide both sides by 30. 15 divided by 30 equals cos theta. This we can cancel now. We get cos theta is half. People, for what angle cos becomes half? When the angle is 60. Therefore, cos theta equals half means theta 60. This implies theta equals 60 degrees. Therefore, angle between the vectors A and B is 60 degrees. Then you can write final answer. Therefore, the angle between vector A and vector B is 60 degrees. 60 degrees. Right? This is how we take that answer. And people will take number 71. Number 71. That's next. Simple A and simple B are two vectors perpendicular to each other. A and B are two vectors. Simple A and simple B are two vectors perpendicular to each other. People, you know, when A and B are two vectors perpendicular to each other, when two vectors are perpendicular, people, what can you say? The dot product. Suppose this is vector A, this is vector B. Then how to write A dot B? Mod A, mod B, cos 90, no. What is cos 90? Cos 90 is 0. When this is 0, whatever this mod A and mod B take, people, this 2, when you multiply with this 0, people, the right hand side is 0. The right hand side is 0. What is this? When two vectors are perpendicular to each other, the dot product of that two vectors is 0. The dot product of these two vectors is 0 when the vectors are perpendicular. Now, people this time asking to prove when A and B are two vectors perpendicular to each other. Perpendicular to each other. Then asking to prove this, A plus B mod perfect square is equal to A minus B mod perfect square. That's what asking to prove. Yeah, people. Okay. Right now, A and B are two vectors perpendicular to each other. Prove that. Then people, A vector is perpendicular to B vector. Then we have to prove. What? A plus B mod perfect squared is equal to A minus B mod perfect squared. Taking vector A and vector B are perpendicular, we have to prove this. But I am going to prove in the other way. But taking these two are equal, I am going to prove vector A is perpendicular to vector B. That's what I supposed to prove. Understand? That's correct, people. A and B are perpendicular vectors. Then we have to prove this. I'm not going to prove this one. I prove the other way. Taking these two are equal, and I prove that. That's also correct. Right. Then I'll give you the method to get this answer. You must try. Very carefully here. People, you know, we proved A dot A is equal to mod A squared. Mod A squared. Like that, people, here we have A plus B mod perfect square, no, here. A plus B means what? A vector. When we add two vectors, people, the answer is another vector. Then A plus B is a vector. Its modulus perfect square can easily be written, people, A plus B dot A plus B. Am I correct? Right? Here, vector A dot vector A, use of this vector modulus perfect square. Like that, A plus B dot A plus B should give A plus B modulus perfect square. Similarly, people, this one we can write A minus B mod perfect square should be A minus B dot A minus B. Then, since we are going to work out this question, how? Starting this one. For this, write people this. For this, write people this. Then, left hand side we have this, right hand side we have this. Then remove the brackets by using the distributive law and keep simplifying these, people. Once you simplify, finally you get, people, your simplified answer finally gives you the result A dot B equals 0. A dot B equals 0. That kind of result you get finally. People, A dot B equals 0 mean when A vector and B vector are non-zero vectors. A and B are two non-zero vectors. A dot B equals 0 means A vector should be perpendicular to B vector, no? A and B are two non-zero vectors, but A dot B equals 0. This can happen only when vector A is perpendicular to vector B. Then correct, no? We have to prove how? A and B are two perpendicular vectors. Then we need to prove this. But we did the other way. What? Taking this as equal, right? And simplifying that, we proved that A and B are two perpendicular vectors. That's the proof, right? Take 5 minutes, people. Try to prove this. Hurry up. Yeah. I take this way. Let A plus B mod perfect square is equal to A minus B mod perfect square. This one you can write A plus B dot A plus B. You see, you can write. right hand side, a minus b dot a minus b. Okay. We can write here a dot a dot b, this plus sign, because here plus, that's plus a dot b, here b dot a and b dot b, that way you can write. Now here a dot a and here plus, here minus a dot b, this and this minus plus minus b dot a, minus plus b dot b. A dot a is people mod a squared. Here b dot a is equal to a dot b. Then this b dot a I can write as a dot b. Then here a dot b plus a dot b, 2 times a dot b. B dot b is mod b perfect square. And here a dot a mod a square. Here people b dot a I can write as a dot b. Here we have minus a dot b. Here also we have minus a dot b. Minus a dot b is what? Minus 2 times a dot b. B dot b means people mod b perfect squared. Right? Yeah. Once you take this mod b perfect squared to right hand side, what do you get? Mod b perfect squared minus mod b perfect squared, that will cancel off. No need to take this mod b perfect square to right hand side to show the cancellation. We'll cancel down like this. Mod a squared, when you take to right hand side people, that will be minus mod a squared. Here we have plus mod a squared. Once you take that to right hand side, minus mod a squared. That too also we can cancel down. Then having this two, here we can cancel down this. Now people will bring this to this side. Then this will be plus. Then here what do you have people? A dot b, and once you bring that this side, plus 2 times a dot b. 2 times a dot b, 2 times a dot b plus 2 times a dot b. It's like 2x plus 2x. It's 4x. Then 4 times a dot b coming. Equals 0. Right. Now, 4 multiplied by this answer is 0. To get the answer 0, when 4 is multiplied by something, to get the answer 0, when 4 is multiplied by something, that thing should be 0, no people? Otherwise, the product will not be equal to 0. So definitely, therefore here, 4 multiplied by this equals 0 means, in order to occur this people, definitely a dot b is equal to 0. Dot product of the two vectors a and b, 0 means people, a should be perpendicular to b. Here a and b vectors are two non-zero vectors. Right? So then this implies what? This implies vector a is perpendicular to vector b. This is how we take this answer. Or else people, the other way also possible to use. But taking a dot b 0, that means a is perpendicular to a vector is perpendicular to b mean a dot b is 0, no? Yeah. The other method, a little. The other method, you can write like this. Since a vector is perpendicular to b vector, a dot b is equal to 0. Now what we do is this. We take A plus B mod perfect square. I write this. A plus B dot A plus B. Now remove the bracket. A dot A plus A dot B, B dot A plus B dot B. A dot B is equal to 0. B dot A is equal to A dot B, no? Then B dot A also 0. Because A and B perpendicular means A dot B 0. And B dot A is equal to A dot B, therefore B dot A also 0. This is 0. This also 0. A dot A means equal mod A squared. B dot B means mod B squared. This is what we get for A plus B mod perfect squared. Say this as number 1. Right. Secondly, we take the answer for this A minus B mod perfect squared. A minus B mod perfect squared. A minus B mod perfect squared. How to write this? A minus B dot A minus B. What do you get there? A dot A minus A dot B minus B dot A minus minus plus B dot B. A dot A means people mod A squared. A dot B is 0 because A and B are perpendicular. B dot A can be written as A dot B. Since A dot B is 0, this is 0, this is 0. Then we get plus B dot B. It is mod B squared. This is number 2. Can you see the right hand sides of number 1 and this number 2 are the same. Therefore, left hand side must be equal. 1 equals 2. Therefore, A plus B mod perfect squared is equal to A minus B mod perfect squared. This way, we get that answer. Yeah. If somebody has a doubt whether we get the answer for the first proof, then you can get rid of your doubt from your mind by doing number 2. First one is correct, right? First proof also correct. Right. We will now take the next one. Yeah, we will take the next question number 76. Number 76. 76. Read people number 76. Number 76. Right, now number 76 people, a parallelogram is constructed on the vector simple A, 3p minus q, and B vector, simple p vector plus 3q vector. Given that modulus of p equals modulus of Q equals 2, and the angle between simple P vector and simple Q vector is pi by 3. Yeah, first of all, we'll pay our attention on P and Q vectors. We vector this, we vector this. The angle between them is pi by 3. And meantime, people, vector P modulus is equal to vector Q modulus is equal to given. But shall we find people P dot Q? P dot Q. Vector P modulus, vector Q modulus cos pi by 3. That's by the definition of P dot Q. Then modulus of P is 2 multiplied by modulus of Q also 2 multiplied by cos pi by 3. Pi by 3 is 60. You know, cos 60 is half. These two you can cancel down. We get 2. Then P dot Q is 2. P dot Q equals 2. Right. Now, people, we are given vector A. Vector A given as 3P vector minus Q. Vector B given simple P plus 3Q. Right? Because for the vector A, there is a line segment. For the vector B also there is a line segment, no? Right? Then the line segment representing vector A, the line segment representing vector B, taking them as the adjacent sides, a parallelogram is constructed. Okay? That's what it says. A parallelogram is constructed on the vector. On the vectors should be there. On the vectors. A and B. Yeah. That says there is a line segment which completely represents the vector A. That is one side. That is one side. Vector B, there is a line segment. That's the other side. They are the two adjacent sides, right, of the parallelogram, like this. Right? This is the vector A. This is the vector B. Right? Vector A and vector B. Right? Then people, you know, when this is a parallelogram, this vector and this vector being equal, no? This vector and this vector are also equal. Okay? Now what is asking? Show that the lengths of the diagonals are 4 root 7 and 4 root 3. Length of the diagonal. Well, I'll take this one. If I take this as A, as B, this as C, this as D. One diagonal is AC. Other diagonal is people BD. Then you can write this AC vector. AC vector is AB plus BC. AB vector plus BC vector. A to B vector is simple A. B to C vector is simple B. This is AC vector. People, A vector given as this 3P minus Q. B vector P plus 3Q. A vector 3P vector minus Q plus B vector P plus 3Q. This is AC vector. That simplify this 3P plus P. What's that? 4P minus Q plus 3Q plus 2Q. This is what we get. People, AC vector is this. Right. Right. Now, AC vector modulus means what, people? AC length. A to C vector modulus is AC length. Right? You know, people, AC squared, that means this AC length is diagonal, no? It's square. You can write how? AC vector modulus perfect square. Correct, no? Modulus of AC means AC length. Then AC length perfect square means AC vector modulus perfect square. Perfect square of the modulus of a vector. We can write. We have proved mod A perfect square is given by A dot A. Like that, AC vector modulus perfect square can easily be then obtained by AC vector dot AC vector. This is AC vector dot AC vector. This AC square. But what is AC vector? This 4P plus 2Q. Dot 4P plus 2Q. This is AC square. Right. Now another little work you have to do, people. What's that? So remove the brackets by using distributive law. This dot this dot this dot this dot this. Wherever you get P dot Q, we have found P dot Q as 2. Wherever you get P dot P, it is mod P perfect square. Mod P is 2, therefore 2 squared. Wherever you get Q dot Q, it is mod Q squared, it is 2 squared. And people, take the answer to this right hand side. Then AC squared is that, then AC means its root. Understood? Then you get this answer. Right. I'll do another 2-3 minutes. Hurry up, people. Right. Now here, what do you get, people? AC squared. 4 and 4 multiplied first 16 P dot P. What is P dot P, people? Mod P squared. I am writing that straight away. This and this now we take 4 and 2 8 P dot Q. Next one, this and this 8 Q dot P. And plus 2 and 2 make 4 Q dot Q. Q dot Q means, people, mod Q perfect square, no? Right. Mod P is 2. Then here 2 squared. 16 multiplied by 2 squared. People, P dot Q. P dot Q we found 2, no? Then here 8 into 2. Here Q dot P is equal to P dot Q, no? Then therefore this is also 2. 8 into 2. And here mod Q is 2. This is 2 squared. 2 squared plus 4 into 2 squared. This is in the left hand side, AC squared. Okay. Now, we'll see how to take this answer. Okay. Then AC squared, we can write people here. Here, 2 squared is 4. Then 16 into 4. 16 multiplied by 4. I write it like this. Here, this is 16. This is 16. 16 plus 16 is 32. 32 I can write people 16 into 2. Then here 2 squared is 4, 4 into 4. Also 16. 16 means people 16 into 1. Then you can take this 16 is common. Take as 16 out. Then this 4 we get within bracket, this 2 we get within bracket, this 1 we get within bracket. 4 plus 2 plus 1 is people 7. Then to find this AC, take the root of 16, it's 4, root of 7 is root 7. Then AC is 4 root 7. AC is 1 diagonal. AC is 1 diagonal, 4 root 7. And people, similarly, the other one, BD, you can take as homework. You know the method now. How to take this BD? First we write BD vector. BD vector, B to D vector is equal to what? BA plus AD. BA plus AD. What is BA vector? Minus A, no? What is AD vector? B. This is B minus A. What is vector B? We are given. Vector A, we are given. Substitute them in terms of P and Q. Now take what people? BD vector dot BD vector. Then simplify. Then this way you get the answer of the other diagram. Right? I leave that as homework. Definitely you must take this answer. Right. Okay. We will come to 77 as the next. We'll take the 77 as the next. Read number 77. Read number 77, people. Number 77 says something like this. Using vector method, show that the diagonals of a rhombus bisect each other at right angles. You know the geometrical properties of a rhombus, people. This is the rhombus. In this rhombus, people, there are some properties. What are the properties of a rhombus? These sides are equal in length. And this diagonals people, when we draw the two diagonals, this way, The diagonals bisect each other at right angles. This length and this length being equal. This length and this length are separately equal. Okay. Now we are asked to prove these two results. I think you can prove these two results by geometry. Using geometry, you can prove these two results. Now this time you are asked to prove this using vector method. Okay. Right. Now this is how I am going to prove these two results. Then we can't take the two results. I will first draw the rhombus like this. The rhombus is drawn like this, huh? Right. And I take this O as the vector origin. This point is A, this is C, this is B. The rhombus is therefore OA, CB. O is the vector origin. We can draw a rhombus so that its one vertex is origin, vector origin. Nobody can say, no, how can it be? Well, it's possible. Vector origin is a point on the plane. Be that point as what one vertex. Can't we draw a rhombus? Possible. That rhombus one they have drawn. Then I am going to take this vector O, this point O as the vector origin. Relative to this origin O, I am going to take the position vector of the point capital A as simple A vector, that of capital B as simple B vector. That way, first of all, we'll draw the rhombus. Understand? Right? Yeah, this is the simple A vector. This is the simple B vector. Then people, this AC vector also simple B. Why? This is a rhombus. We know the properties of the rhombus. Opposite sides are equal and parallel. That's the reason. And this BC vector also simple A vector. Understood? Right. Then first draw this rhombus and then we'll write one sentence like this. We'll write one sentence like this. Right, hurry up, people. In a rhombus, all four sides are equal, people. No? In rhombus, all four sides are equal in length. Right. Write down like this. Let the rhombus be OACB. Relative to the point O, let the position vectors of the points capital A and capital B, capital A and capital B, capital A and capital B, B, another B, last B is BEB, right? The position vectors of the points capital A and capital BB, simple A vector and simple B vector respectively. Simple A vector and simple B vector respectively. Simple A vector, underline simple A, simple B vector, underline simple B. Right. People, you know, the four sides of a rhombus are equal in length. Since we can write, since OA length is equal to OB length, OA length and OB length being equal. OA length means, people, modulus of A, OB means modulus of B. Then modulus of A is equal to modulus of B. Right? OA length and OB length being equal, because in rhombus all four sides are equal in length. Right. Now, first thing I have to prove is what, people? This OC diagonal is perpendicular to this AB diagonal. That's what I have to prove first. OC diagonal is perpendicular to this AB diagonal. Then for this, what I do is, people, I first write OC vector. How to write OC vector? By the triangle of vector addition, OC vector I can write as OA plus AC. OA plus AC is OC vector. That means A vector plus B vector. Vector A plus vector B. Secondly, I am going to find, people, A to B vector, AB vector. AB vector. AB vector is AO plus OB. AO is minus A, OB is B. Minus A vector plus B vector. Minus A vector plus B vector means B minus A vector. Okay. Now what I do is this, people. OC and OB, I take a dot product. I take dot product of OC vector and OB vector. OC vector is, people, A plus B vector. Wait, OC and AB I take. OC and AB vector I take, because I need to prove OC and AB diagonals are perpendicular. No. Yeah, then I take OC vector dot AB vector. OC vector A plus B, AB vector B minus A. Then apply to the right hand side distributive law, A dot B. Minus A dot A plus B dot B minus B dot A. People, A dot B, here B dot A. B dot A means A dot B, no? Then this is minus A dot B. This is plus A dot B. These two we can cancel now. A dot A means what, people? Mod A squared. Before that we have minus sign. Minus, this is mod A squared plus B dot B. What is that, people? Mod B squared. You can try this on this way. The same thing, this one I have written. Mod B squared minus mod A squared. People, but you know what? Mod A and mod B being equal. Mod A and mod B, mod A and mod B are equal, people. Then this and this being equal. This mod B squared and this mod A squared are equal. Therefore, their difference should be 0, no? It's like 10 minus 10, 0. Then this is OC dot AB. The dot product of the vectors OC and AB is 0. Then this says us, people, OC vector and this AB vector are perpendicular. And this implies OC vector is perpendicular to this AB vector. That means what, people? OC line and AB line are perpendicular. That means the diagonals of the rhombus are perpendicular. Then you can write, therefore, the diagonals of rhombus are perpendicular. One part of the proof we have done. The two diagonals are perpendicular to each other. Another one is there. What is that? They intersect at a point here. Right? We have to prove this length and this length being equal, and this length and this length being separately equal. That's also another one to prove there. By now, people, we have proved this angle is 90. That is one part of the proof. Another part is there. What is that? This point is the midpoint of this OC and AB both. If we can prove this is the midpoint of OC and AB both, then second part also okay. What is that? If this is the midpoint, okay, then this diagonal bisect this one. This diagonal bisect this one. That is the meaning of they bisect each other at right angles, means the angle between them is 90. Okay. To prove that, this is what I do. I take the midpoint of AB as, people, D. Midpoint of AB I am going to take as D. Then I can't take D here, because that is the one we have to prove. No? Therefore, you can't take that midpoint of this AB here. Then already we know this point is the midpoint. Then there is nothing to prove. No? Okay. And midpoint of OC I am going to take as E. And I am marking E somewhere here. Then this D is the midpoint of AB. E is the midpoint of OC. D lies on AB. E lies on OC. I am going to show this point D coincide with point E. Point D overlap with point E. That means D and E are not 2 points, right? They are the same point, only 1 point. That means what? D, E should coincide, overlap. But definitely E should be somewhere on OC, because E is the midpoint of OC, no? So it should be on OC. Point D should be somewhere on AB, because D is the midpoint of people AB. When D and E coincide, mean, people, right? D must be on AB as well as on OC. Point E also should be on OC and as well as AB. Why? D and E coincide. No? Then what is the point for the midpoints of OC and AB to lie? That midpoints, that D should be on AB and OC. Why, people? D and E coincide, no? Then the point D should be on OC also, because E is on OC, no? D and E coincide means D should come to what? OC. But D can't go out on the line AB because D is the midpoint of AB. Then the point D should be AB as well as OC. Similarly, point E should be on OC as well as on AB. Then what are the possible locations to lie both D and E? These people. This is the point that lies on OC and AB. So therefore, the midpoints of AB should be here. Midpoint of OC should be here. That says what? This is the midpoint of AB and OC both. That means what? This intersection point bisect the diagonals each other. Since earlier we have proved this angle as 90, people, the diagonals of a rhombus bisect each other at right angles. That's how we complete the proof. Understood, people? Yeah. Then we'll prove that. Write down like this. Let the midpoint of AB, let the midpoint of AB B, AB, B, B, E, B, capital D, and midpoint of OC, B, B, E, B, capital E. Right now, people. Okay. Now, how to write OE vector? Now, OE vector. People, OE vector, how to write? E is the midpoint of OC, no? Then OE, we can write half of OC, half of OC, right now? OE vector, I can write half of OC vector because E is the midpoint of OC. OC vector is this. Half OC vector, vector E plus vector B. Right. People, I am going to write OD vector. OD vector. OD vector. Tell me what is OD vector? OD vector is equal to OA vector plus AD vector. OA vector is equal to simple A vector. What is AD vector? This is the midpoint of AB, no? Then AD vector is half of AB vector. AD vector is half of AB vector. What is AB vector? It's B minus A. Now simplify this. OD vector is equal to, take here common dividend as 2, then this is 2A plus B minus A. 2A minus A is A plus B divided by 2. This is OD vector. A plus B divided by 2 means, people, half of A plus B, right? Half times A plus B. Then you can see here half times A plus B we got for this OE. Here also half times A plus B we got for this OD. Therefore, you can write OE vector and OD vector are equal. OE vector, this O to E vector and O to D vector. are equal. When two vectors are equal, people, this says what? OE parallel to OD, and number 2 is OE length is equal to OD length. When two vectors are equal, the corresponding line segments are parallel. Also, the corresponding line segments are equal in length. People, from the same point O, both the line segments OD and OE start. Starting from a point when two line segments are going out, and if they are parallel, they can't be two line segments, they should be overlapped. The two line segments should be on the same line, right? Then if I draw that way, OE here, this is O, OD here. These two must be parallel according to this. This we got by this equal two vectors. OD and OE being parallel means, people, either this OD should come this OE, and OE should come onto this OD. Anyway, people, OD, OE on the same line, or in other words, ODE should be collinear. This way, ODE collinear. By this OE equal OD mean, people, O to D length and O to E length should be equal. That means, people, either this D should go to this E, or E should come to this D. Anyhow, people, this says D and E coincide. And therefore, by these two results, you can see, hence, D, E coincide. D and E are coincident points. Hence, the point D and E coincide. Coincide means, people, overlap each other. Coincide. That means what? Midpoint of OC and midpoint of AB coincide. Coincide. D and E should be the same point. Okay. Therefore, the possible location to lie this D and E should be this. Okay. Why? Point D should be definitely somewhere on AB. Since D overlaps with this E, that point D should also be on OC. Then D should be on AB as well as on OC. Therefore, this is the point to lie this point D. Again, point E should be on this OC as well as point E should be on this AB, because E and D coincide. So therefore, for the point E, the point to lie is this. That means what? This should be the midpoints of OC and AB. And then you can write, therefore, the point of intersection of OC and AB, therefore the point of intersection of OC and AB should be the midpoints of OC and AB. Right on, last answer. Hence, the diagonals of a rhombus bisect each other at right angles. We will take question number 80, part 3. Question number 80, part 3. Proof of the Pythagorean theorem using the vector dot product. Proof of the Pythagorean theorem. Right. We will try this question. I give 2-3 minutes because always I am giving the question name, answering. Yeah. This is how people we prove the Pythagorean theorem using vector dot product. Now, I take this people here. This is the right angle, triangle. The Pythagorean theorem is true only for a right angle triangle like this. No? So this angle be 90. This is be A, this is B, this is C. I take this A to B vector as simple A vector and A to C vector as simple B vector. Okay. Then this angle is 90, no? Then vectors simple A and simple B are perpendicular vectors. Simple A vector and simple B vector are perpendicular vectors. When two vectors are perpendicular, people, the dot product of that two vectors is 0. Right. First draw the diagram, people. Draw the diagram. And we'll write one sentence like this. Pattern like this. Let the triangle, let the right angle triangle, let the right angled triangle VEB, capital ABC, capital ABC, with angle A pi by 2. Angle A pi by 2. Again write, let AB vector is equal to simple A vector and AC vector is equal to simple B vector. AC vector is equal to simple B vector. Then you can write, people, then BC vector B to C vector. We can write how? B to C vector we can write BA plus AC. BA vector plus AC vector is the BC vector. B to A vector is people minus A vector. Minus A vector. A to C vector is B. Then this is BC. B minus A. Now you know also AB vector is perpendicular to AC vector. That's well obvious fact, people. Here, AB vector, this is AC vector. Angle between them is 90. Angle between them is 90. The two vectors, people, AB, AC, perpendicular. That means vector A perpendicular to vector B. Therefore, A dot B equals 0. Understood? A dot B is equal to 0. Now what we do is this, people. Now, right, we take BC dot BC. We take the dot product of BC with itself. BC dot BC. What is BC vector? B minus A. Dot BC. B minus A. BC dot BC means, people, what? BC vector modulus perfect square. Correct, no? When you take the dot product of a vector with itself, we get the perfect square of the modulus of that vector. When we remove the bracket, B dot B minus B dot A. Next one, minus A dot B. Minus minus plus A dot T. People, B dot T means equal to A dot B, no, but A dot B is 0. Here also 0. Here B dot B means what? Mod B perfect square. A dot T mod A perfect square. BC vector modulus perfect square. What is, people, this modulus of the BC vector? Is BC length, no? Modulus of BC vector means BC length. BC length perfect square, this. Mod B perfect square. People, what is vector B? Vector B means AC vector. Its modulus means AC length. Therefore, this is AC length perfect square plus mod A perfect square. A is this vector. Then modulus of this vector means AB length. Then mod A means AB length. AB length perfect square is equal to BC square. Correct, no, people? This implies what? AC square plus AB square is equal to BC square. AC square means square of this plus AB square means square of this. That is equal to BC square. What is this? Is the Pythagoras theorem, no? Is the Pythagoras theorem. Right, people? That's how we put that part. Yeah. Right, people, take question number 80, part 1 as the next. Question number 80, part 1. Question number 80, part 1. Read question number 80, part 1. Yeah, this is, people, when we consider a circle, when we consider a circle, you see, people, suppose a circle. In the circle, people, we know one geometrical theorem. This is a diameter. This is center. This length is called as a diameter. When these two ends of this diameter are joined to any point on the circumference of the circle, these two ends of this diameter, we join to any point on the circumference of the circle, then you know this angle is 90. This angle is 90. This theorem is, of course, sometimes given as the angle of a semicircle is 90 degrees. The angle of a semicircle is 90 degrees. That way also this theorem usually given, right? Okay, this is the one we have to prove, right? Even I'm going to put it like this. I take this point as O. This is C. This is B. This is C. Okay. Then I need to prove this angle is 90. Okay. This is the center of the circle. I take this, you know, this OA length and OB length are equal. Why, people? The same radius, no? OA length and OB length are equal. Same radius. I take this OC. This OC vector, I take like this. Then OC also what, people? A radius. Therefore, these three are equal in length because all are radii. All are radii. Well, now, if I take this O to A vector as simple A, what is O to B vector? We are going to the right. Then it is A. Then when we come back, that is to say, going O to B. OB vector should be minus A, no? The same size, same line, only the direction is opposite. Therefore, the vector should be minus. OB vector should be minus A. And I'm going to take this vector OC as simple R vector. OC vector, I am going to take as simple R vector. Understand? Right. First of all, diagram. Okay. Pattern like this. Let the center of the circle be O. Let the center of the circle be O. And let capital A be. Let capital A be capital A B. Be a diameter. AB be a diameter. Capital A B. And second B is BEB. Capital A B B. A diameter. Write down now. Let us join the points capital A and capital B. Let us join the points capital A and capital B to a point C, on the circle. Okay. Now people, we can write. Now let OA vector simple A vector, then OB vector minus simple A. Also let OC vector is equal to R vector. OC vector is equal to R vector. People, you know, OC length and OA length being equal, no? The same radius, no? And now we can write, since OA length is equal to OC length, right? What is OA length? O to A length means simple A modulus. Right? O to C length means what, people? Simple R modulus. Simple R modulus. OA mean, people, what? OA vector modulus. But OA vector only we have taken as simple A. Therefore, OA length means simple A modulus. Right. Now, first I am going to find this CB vector. Secondly, I am going to find the CA vector. What is CB vector? CB vector, how to write? CB vector we can write, C to B vector we can write CO plus OB. CO plus OB. CO plus OB. What is people CO vector? C to O vector is minus R. O to B vector minus A. Then we can take people here minus sign out. Then within bracket we get R plus A vector. This is CB vector. Now we find CA vector. CA vector. C to A vector you can write how, people? CO plus OA. CO plus OA. What is because CO? Minus R. OA plus A. This is CA. Minus R plus A means, people, A minus R. This is CA vector. Okay. Now what we do is, people, we take the dot product of CB vector and CA vector. CB vector and CA vector. We take the dot product. CB vector is minus R plus A dot. This is A minus R. I take this minus sign out. Now I use the distributive law property. What is that, people? R dot A minus R dot R plus A dot A minus A dot R. People, this A dot R you can write as R dot A. A dot R you can write as R dot A. Here we have minus R dot A. Here we have plus R dot A. These two you can cancel now. Now A dot A, it is what, people? Mod A squared minus R dot R, mod R squared. But people, you know, mod A and mod R being equal. We said that before. Then this mod A squared minus mod R squared means what? This is 0. Minus sign in 0 means this is really 0. This is CB dot CA. CB vector dot CA vector equals 0. That means what, people? CB vector and CA vector are perpendicular. And this implies what? CB vector is perpendicular to what? CA vector. CB vector perpendicular CA means what, people? This line and this line being perpendicular. That means what? ACB 90. This implies ACB angle is 90. That is what we say. The angle in a semicircle is 90 degrees. Understood, people? This is how we prove. Right? The cosine rule for a triangle also, people, we can prove by using this vector dot product. That proof and some other proof next year we discuss in this lesson. And people, another at the most 3 classes we have to do to finish for this lesson completely, or else 4 classes, because some partial sums also I supposed to do. Right? After that, people will start another new lesson. Right? Okay, now people try the questions as homework. Next Friday, we continue the class from here. Any question here?